I want you to take a second and just picture holding a ripe autumn fig right in the palm of your
Oh,
hand.
yeah, you know the exact kind.
Right. It's got that plump, slightly heavy, tear-shaped body. The skin is this incredible bruised purple or maybe, you know, a rich golden green, and it just gives softly to the touch when you press it.
And then when you pull it apart, the inside reveals this glistening tapestry of tiny edible seeds.
Yeah, all embedded in that jammy, intensely honey-sweet flesh. I mean, it is a completely unique sensory experience.
It really is. And it's an experience humans have been obsessing over for millennia. If you look back across ancient Mediterranean and Middle Eastern cultures,
Yeah.
the fig wasn't just treated as like a standard crop.
No, it was deeply revered.
Exactly. You see it in the art, the mythology, the early medicinal texts. It was this really potent symbol of abundance
Yeah.
and life-sustaining vitality.
Wow.
Yeah, ancient armies would actually march on rations of figs because they intuitively understood it provided a very specific kind of endurance.
Which, honestly, perfectly sets up our mission for this deep dive. We have a fantastic set of nutritional notes in front of us today.
We do. Specifically, a really compelling breakdown by Dr. Maya Lin.
Yes, focusing on the science of seasonal eating. So we are going to look past the fig's modern reputation as just, a simple sweet addition to a charcuterie board.
Right, there's so much more to it.
There really is. We're unpacking the surprisingly complex biological science hidden inside this ancient delicacy. So, okay, let's unpack this. Because pulling apart a fresh fig is less like eating a standard piece of fruit and much more like cracking open a biological treasure chest that seems engineered specifically for the autumn season.
I love that phrase.
Yeah.
Engineered for autumn is a great framework for Dr. Lin's notes. Because when we talk about seasonal eating, it isn't just an aesthetic lifestyle choice about, like, wearing sweaters and drinking cider.
Right, it's not just a vibe.
Exactly. It's about recognizing how our internal biology is forced to interact with our shifting environment. As the daylight hours shorten and temperatures drop, our circadian rhythms change and our metabolic demands actually shift.
So we naturally begin craving heavier, warmer comfort foods, I assume.
Spot on. Root vegetables, dense meats, thick stews. Those foods are deeply satisfying and, well, necessary for warmth, but they place a massive immediate demand on the digestive system.
I mean, think about how you feel after a heavy Thanksgiving dinner or like a massive Sunday roast in November.
Oh, yeah. The food coma.
Exactly. You get that incredibly heavy, sluggish feeling. Your stomach feels like it just hit a wall.
And that's mostly because it's suddenly tasked with breaking down all these dense, complex proteins and fats after months of processing lighter summer foods. The physical toll on the gastrointestinal tract during that transition is significant.
The stomach has to ramp up acid production, right?
Yeah, and the pancreas works overtime. And this is where the specific biology of the fresh fig comes into play. The first line of defense it offers is its legendary dietary fiber content.
Right.
We are talking about a very dense matrix of both soluble and insoluble fiber. The insoluble fiber adds the necessary physical bulk to keep the digestive tract moving, physically sweeping the intestines to prevent that exact sluggishness we just talked about.
But I mean, if you are eating a heavy beef stew, fiber alone doesn't explain why a fig helps your stomach process the meal. Because fiber is just the bulk.
Right.
Because fiber doesn't actually digest the food for you, it just moves it along. So there has to be something active happening here. Something that's actually helping the stomach do the heavy lifting of breaking down that roast.
You're exactly right. There is a very active mechanism at work. What's fascinating here is that the fig contains a unique, naturally occurring proteolytic enzyme called ficin.
Fission, I say.
Yeah, F-I-C-I-N. If you want to understand its function, you can look at papain in papayas or bromelain in pineapples.
Oh, I've heard of those.
Yeah, which are also proteolytic enzymes. Their specific biological mandate is to seek out protein molecules and cleave the peptide bonds holding them together.
Wait, so it's actively dismantling the chemical structure of those heavy comfort foods?
Down to the molecular level. I mean, proteins are incredibly complex, tightly folded structures. Imagine a massive, tangled ball of yarn.
Okay, I'm picturing it.
When you eat a heavy piece of meat, your stomach has to flood the environment with hydrochloric acid and its own enzymes to slowly untangle and snip that yarn into usable single strands.
Which are the amino acids.
Exactly. Ficin steps in and acts as an external catalyst. It starts chemically snipping those peptide bonds the moment it mixes with the food in your stomach.
So ficin is essentially a microscopic sous chef in our gut.
A sous chef.
Yeah. It's doing the prep work, chopping up these massive protein molecules so our stomach's own enzymes don't have to work overtime to get the job done.
Honestly, the sous chef analogy tracks perfectly with the biology. Because ficein's doing that preliminary chemical chopping, your stomach doesn't need to produce as much acid.
Wow.
And the physical strain on your digestive organs is dramatically reduced. The nutrients from your heavy autumn meals can be assimilated into the body much more smoothly. A fresh fig is essentially a highly effective digestive enzyme supplement packaged inside a fiber delivery system.
Okay, so if ficin is breaking down these complex proteins so efficiently, and the digestive tract is suddenly operating at peak efficiency without getting bogged down,
Right.
what happens next? Like, the stomach is suddenly absorbing a massive payload of nutrients all at once. What exactly is flooding from the gut into the bloodstream when you eat a fig?
This is where Dr. Lin's research transitions from gut mechanics to blood and bone chemistry. The sheer mineral density of the fig is staggering once you break down the nutritional profile.
Like, how staggering.
Well, it delivers a massive payload of essential minerals, specifically high concentrations of calcium, magnesium, potassium, and iron.
Okay, I'm having a hard time wrapping my head around this. Here's where it gets really interesting. Usually, if I want a calcium payload, my brain automatically goes to the dairy aisle for milk or yogurt.
Right, of course.
And if I need potassium to recover, I'm grabbing a banana or like a sports drink. Are you saying a single fleshy autumn fruit is actively competing with those staples on a mineral level?
It absolutely competes. Fresh figs are recognized as one of the most potent plant-based sources of calcium available among common fruits.
That's crazy.
It is, but looking at a list of minerals on a nutritional label only tells half the story. If we connect this to the bigger picture, what makes the fig biologically remarkable is the synergy of its mineral payload.
Synergy, meaning how they work together.
Exactly. Take calcium and magnesium. You can consume all the calcium in the world, but if you don't have adequate magnesium, your body cannot properly utilize it.
Because the minerals have to interact with each other to work.
Yes, magnesium is basically the biochemical key that unlocks calcium absorption. Without magnesium, calcium can actually just build up in the bloodstream or calcify in soft tissues.
Oh, which isn't helpful at all.
Not at all. Magnesium stimulates the hormone calcitonin, which essentially tells the body to draw calcium out of the blood and tissues and put it directly into the bone matrix.
I see.
So by organically packaging calcium and magnesium together in such high quantities, the fig provides both the building block and the hormonal trigger required to actually maintain strong bone mineral density.
It's delivering the bricks and the cement mixer at the exact same time.
That is a great way to picture it. And while that construction project is happening in the skeletal system, you have the potassium entering the bloodstream to address a completely different seasonal challenge.
Right, because we mentioned potassium earlier,
Potassium operates at the cellular level, specifically interacting with sodium.
which feels incredibly relevant given those autumn comfort foods we keep talking about, like stews, roasts, gravies, cured meats. They all tend to be heavily salted.
Oh, they are loaded with sodium. And when you consume high levels of sodium, it pulls water into your blood vessels, increasing the volume of blood.
And consequently driving up your blood pressure.
Exactly. Potassium acts on the cellular pump to push sodium out of the cells. It essentially relaxes the walls of the blood vessels.
So potassium is the chemical counterbalance. You eat the salty autumn meal, your blood pressure wants to spike, but the potassium from the fig steps in to flush the excess sodium and relax the vascular system.
Yes, it regulates cellular fluid balance and stabilizes blood pressure. Stepping back to look at the seasonal eating philosophy Dr. Lin outlines, this is profound.
It really is.
As temperatures drop, your cardiovascular system naturally works harder to maintain core body heat. By flooding the bloodstream with this specific mineral synergy, the fig is fortifying your bone structure and actively protecting cardiovascular function when environmental stress is at its highest.
That completely changes how I'll look at the produce aisle. It's like an internal armor against the winter transition.
Truly.
But I have to bring up something that feels like a massive biological contradiction here.
Okay, what is it?
Well, we're talking about this hyper-functional, mineral-dense, heart-protecting health food, but its flesh tastes like literal, intense, honey-sweet jam.
It really does.
It is one of the sweetest things you can possibly pull off a tree. Usually when a food tastes that much like candy, there is a severe metabolic catch. Like, how does this not just act as a giant sugar bomb that wrecks your insulin levels?
The sweetness paradox is usually the first red flag for anyone looking at nutrition.
Mm-hmm.
If something tastes like jam, We just assume it's going to spike our blood glucose.
Right.
To understand why the fig doesn't cause metabolic chaos, we first have to draw a hard scientific line between dried figs and fresh figs.
Because the drying process changes the chemical makeup.
It changes the concentration. When you dehydrate a fig, you extract the water, which leaves the natural fructose highly concentrated.
Okay, that makes sense.
A dried fig is undeniably high in concentrated sugar and will impact your blood glucose much faster. But a fresh fig, retaining all its water and structural integrity, operates very differently.
Right.
Yeah, despite that intense jammy flavor, fresh figs actually possess a surprisingly moderate glycemic index.
Wait, a moderate glycemic index, even though it tastes sweeter than an apple or a berry?
Yes. And historically, culinary traditions intuitively knew how to optimize this even further.
How so?
Think about how fresh figs are traditionally served in Mediterranean diets. You almost always see them paired with healthy fats or proteins.
Oh, like stuffed with goat cheese or wrapped in prosciutto?
Exactly, or served over walnuts. The fats and proteins in those foods physically slow down the digestive process even more, stabilizing the body's glycemic response to the fruit's natural sugars.
It's fascinating when ancient culinary pairings turn out to be perfectly calibrated nutritional science. But even if you eat the fig on its own, I mean, it has to have its own internal defense mechanism for that sugar, right?
It does. This raises an important question, and it relies on two distinct biological systems. The first involves the chemical compounds packaged alongside the sugar, specifically a dense concentration of polyphenols and flavonoids.
We hear the word polyphenols thrown around constantly in health circles, usually alongside things like green tea or dark chocolate. What are they actually doing inside the body when we eat a sweet fig?
Polyphenols are powerful plant compounds that actively interact with our cellular receptors. When you consume a high amount of simple sugar, your cells can become overwhelmed.
So they stop listening.
They essentially stop listening to insulin, which is the hormone trying to shuttle the sugar out of the blood and into the cell for energy. This is what we call insulin resistance.
Right, okay.
The polyphenols in fresh figs, and notably highly concentrated in fig leaves as well, act as cellular messengers.
Oh, so they change how the cells respond to the sugar.
They reduce local oxidative stress and inflammation around the cells, which effectively cleans the receptors. This allows the cells to hear the insulin signal much more clearly.
That's incredible.
So, the fig delivers natural sugar for energy, but it simultaneously delivers the exact polyphenols required to improve insulin sensitivity, ensuring that sugar is actually utilized by the muscles and organs rather than backing up in the bloodstream.
Okay, so chemically, it's prepping the cells to receive the sugar. But doesn't the speed at which that sugar hits the bloodstream still matter?
It absolutely does.
Like, if a massive wave of sugar hits your system all at once, even sensitized cells might get overwhelmed.
The speed of absorption is the most critical factor, and this is where the fig's physical structure provides its second and honestly most brilliant defense mechanism. Fresh figs have an exceptionally high mucilage content.
Mucilage. It sounds like something you'd find in a biology lab.
It does, but it's a very specific type of soluble fiber. When mucilage comes into contact with water and stomach acids in the digestive tract, it undergoes a physical change.
What kind of change?
It swells and forms a thick, viscous, gel-like consistency. This gel coats the stomach lining and physically slows down the rate of gastric emptying.
So instead of the food being processed and dumped rapidly into the small intestine where the sugar gets absorbed, this mucilage gel acts as a physical roadblock, literally slowing the whole system down.
Exactly. It controls the transit time. Because the mucilage turns the stomach contents into a slow-moving gel, the natural fructose from the fig isn't allowed to flood the small intestine all at once.
Ah.
It forces the sugars to drip into the intestinal tract and, consequently, into the bloodstream gradually over an extended period.
So what does this all mean? If we go back to like a nightclub bouncer analogy,
I love that.
you have all these natural sugars trying to rush the doors of the bloodstream at once. But the mucilage steps in, puts up the velvet rope, and says, hold on, nobody rushes the door. We're letting you in two at a time.
Exactly.
It forces an orderly line which prevents the pancreas from having to panic and dump a massive spike of insulin to handle a riot.
The bouncer keeps the metabolic peace. By wrapping the natural sugars inside that mucilage gel and coupling it with polyphenols that prime the cell receptors, the fresh fig allows you to satisfy a very human craving for autumn sweetness.
Right.
But it does so in a way that meticulously respects and supports your body's glucose metabolism, preventing the energy crash that usually follows sweet treats.
It is genuinely a masterclass in functional nutrition. Let's synthesize all of this for you listening because Dr. Lin's notes paint a remarkable picture of what happens inside your biology as the seasons change.
They really do.
As the weather gets colder, the days get shorter, and your diet naturally shifts toward those heavier, warmer comfort foods, the fresh fig offers this brilliant three-pronged defense system.
Yes.
First, you have the gut support. You're getting the sweeping action of the fiber combined with our microscopic sous chef, the fission enzyme, aggressively breaking down complex proteins to prevent autumn sluggishness.
So important.
Second, you have the structural and cardiovascular armor. It delivers a mineral payload where magnesium unlocks calcium for your bones, and potassium flushes excess sodium to protect your blood pressure.
The bricks in the cement mixer.
Exactly. And third, you get to satisfy your sweet tooth safely because those mucilage roadblocks and cell-priming polyphenols ensure the sugar is absorbed slowly and utilized efficiently.
It is a phenomenal biological package. And looking at all this validated, microscopic modern science leaves us with a really compelling thought to explore.
Oh, what's that?
Well, we touched on this at the very beginning, the fact that ancient Mediterranean cultures revered the fig. They carved it into temples and prescribed it in ancient texts as a source of vitality and endurance thousands of years ago.
Thousands of years before anyone had a laboratory to isolate a proteolytic enzyme or map a cellular insulin receptor.
They had no microscopes. They had no concept of a glycemic index or a sodium-potassium cellular pump. Yet, through observation and intuitive connection to their environment, they fully understood the profound, life-sustaining value of this fruit.
It's wild to think about.
It raises a fascinating question about our modern food systems. If our ancestors were that deeply attuned to the biological magic of the fig, long before science could explain it, what other ancient mythological superfoods are just sitting quietly in our grocery store produce aisles right now, waiting for modern technology to finally catch up and decode their mechanisms?
That is a brilliant thought to take with you on your next grocery run. I highly encourage you to go grab some fresh autumn figs this week. Find the plumpest, deepest purple ones you can.
Yes, definitely.
Pick up some goat cheese and walnuts to test out that culinary synergy and experience this seasonal science for yourself. Next time you find yourself holding that tear-shaped fruit about to pull apart that honey-sweet center, just remember, you aren't just eating a snack. You are consuming a piece of ancient wisdom, perfectly engineered for the season and completely validated by modern biology.